Okay, we are seeing another integral here. It says integrate dx over root of 3 plus 6x minus x squared. Of course, dx. Now, this is an integral we can handle using the sine inverse substitution. The sine inverse substitution says if we have the integral dx over a squared minus b squared, x squared is the same as 1 over b sine inverse of b over a x. So now we are going to try to express this denominator into this form. Of course, that calls for computing squares. So we first compute squares for this, but before we compute squares, we said we make sure that always the coefficient of the highest power x squared in this case is always a 1. To see or to go through those videos, you can visit the playlists. All those methods of computing squares are there. But please don't forget to subscribe to the channel. Okay, let's start by computing squares for this. So now, to compute squares for this, you see I have 3 plus 6x minus x squared. We say this coefficient should be 1 first. So I'm going first start by factorizing out negative. So this will be now negative into x squared. Now this one becomes minus 6x, then minus 3. So now I can able now compute squares. This will be now negative into, we said you write the whole of this minus 6x, then you get the coefficient of x, you multiply it with a half, then after you square it. So the coefficient of x is negative 6. If I multiply it with a half, I get negative 3. So the negative 3, you add it, you square it. Because it wasn't there, you remove it. Then you can able bring this one here, this constant we had originally as negative 3. And so from there, you can able see this is the same as negative into the whole of this now. This is a perfect square. We can write as x minus 3, the whole squared. You see, if I expand this, I will say square the first term, this and this then by 2, then square the last term there. So the whole of this is in there. So when you simplify this, we have minus, when we square negative 3, we get 9. And this negative, then this negative, we shall get negative 12. They're all in there. Then after that, we can open brackets for this negative. So we shall be having a negative, and negative shall have positive 12, then minus x minus 3, the whole squared. Be careful here, this negative cannot enter because this one is locked. So meaning the whole of 3 plus 6x minus x squared is equal to that. Implying that now my integral dx over root of, now this one is going to be 3, but now I have it as 12 minus x minus 3, the whole squared. You see, now to have this, we need to be having a square here. So see, this one works if this one is having a square. Here it is 1 squared, which is okay. So to create a square here without changing anything, this is the same as dx over square root of. Now to create a square here is by creating a square root of 12, and then at the same time I remove that square root. This is the same thing when I square root 12, I'll come back to 12, so I've done nothing in simple terms. Then minus into, so then I'll come and I put my minus into the whole of this x minus 3, the whole squared. So from here, you can now compare our a. If you compare with this, my a, you can able to see that my a is going to be, if you compare, it's going to be root 12. Then my b, you see here we have 1 squared. It's going to be 1. Then my x is going to be represented by x minus 3. Then we just apply, and then we just substitute into this. So this will be now 1 over b, which is 1. Then sine inverse of b, which is 1 over 12, the a, which is root 12. Then our x, you see it's the same as, it's represented by that in simple terms. So meaning that now, ladies and gentlemen, my integral, so the whole of now that integral there, so my integral dx over root of 3 plus 6x minus x squared is going to be 1 over 1 is 1, of course. It's going to be sine inverse in brackets of this one. You can rationalize if you want. You can rationalize this by multiplying it up and down. So we are having root 12 over 12, which you can see a square number there, but that's not the order of the day. So minus 3, the whole of that, then plus our constant of integration there, which we can also add there. So now that's how we can handle that integral there. So that's it. You can go further to simplify this, because you can see this is the same as 2 root 3. That 2 cancels anyway. If I simplify further, this will be the same as sine inverse of, this is the same as 2 root 3. So the 2 cancels. I have root 3 up over 6. Then sine inverse of x minus 3. I mean x minus 3, the whole into that one. Sorry, into that one bracket. And I said this is the same as 2 root 3. So the 2 will cancel. So I have now root 3 over 6 into now this, which is x minus 3. And so that's how we can do that number, then plus a constant of integration. So if you wanted to simplify, that's how far you can simplify that. That's it, members. I wish you well. You can try more methods. That's what I think it's easier.